advancement of agriculture reform, modern technology is closely related to the development of agriculture. The sustainable development of modern agriculture is no longer limited to the use of natural resources but also indicates the understanding and control of information sources. In recent years, the continuous deterioration of ecological environment makes the ecological structure more fragile. Crop disease and insect pests often have large-scale outbreaks. Frequently, outbreaks of crop diseases and insect pests directly affect the quantity and quality of agriculture products, resulting in economic losses. Therefore, it is necessary to control the crop diseases and insect pests to avoid unnecessary losses. The main project was focused on the prediction of diseases of the crop and also pests to reduce economical losses in using with the CNN algorithm, convolutional neural network algorithm. Hardware requirements: operating system Windows, processor i5 and above, RAM should be 4 GB and above, hard disk should be 20 GB and above. Coming to the software requirements, we need to install Python with a version of 3.7. Methodologies: to implement this project, we have designed few modules. First one, upload crop disease dataset. By this model, we are going to upload the dataset to this application. Next one, image pre-processing and normalization module. In this module, we are going to read and resize the image and then normalize the image dataset based upon the whatever the crop disease dataset we have uploaded. Then third module, build crop disease recognition model. In this model, we are going to split the dataset into two parts, as the 80% of dataset for the training of the application and 20% of dataset for the testing of the application. And trained dataset is used to build the model CNN algorithm, and test dataset is used to predict the accuracy, precision and recall score. Then next module, upload test image and predict diseases. In this module, we are going to upload the images based upon the test image dataset and predict the diseases based upon the CNN algorithm. Then last module, accuracy and loss graph. In this module, we will plot the comparison graphical representation of accuracy and loss of the CNN model. Then coming to the execution, close this file and go to the code file, and this is the code file, consists of crop disease dataset and also plant disease dataset. Then coming to the next, this is the model file, which consists of pickle file, .h5 file and .npy file. Pickle file is a serialized data format in Python used for object serialization. It allows you to save Python objects into a file and later record them back into the memory. Load back into the memory. Then next one, .h5 file. This .h5 file contains algorithms information and can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making prediction on the new data or performing specific operations. Next one, .npy format. It is a standard binary file format in NumPy for persisting a single arbitrary NumPy array on the disk. The format stores all of the shapes and data types information necessary to reconstruct the array correctly, even on the another machine with a different architecture. And next file, these are the test files used for testing the data set with the algorithm CNN, and these are the code files. And this is the run bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the program. By clicking double tap on it, it leads to the graphical user interface which interactive with the program user. And first button, click on the first button, it is upload crop disease dataset. By clicking this button, you can see the dialog box open and select the dataset for training the algorithm. So dataset is loaded. The next one, click on the image processing and normalization. By clicking this button, you can see that image was read and resized and also normalized. And by clicking the close of the image, you can see the image processing was completed. And next button will crop disease recognition. By clicking this button, you can see the CNN was run in the back console with the different layers and dimensions and dropouts, and you can see on the graphical user interface the accuracy score of the CNN algorithm in the crop disease recognition model prediction. The next one, upload test image and predict disease button. By clicking this button, it will show the dialog box and select any of the leaf, and it will show that crop disease recognized as potato leaf healthy. So you want to test with the another image, then click on the same button and select the one more leaf image. So here you can see that crop disease recognized as potato early light disease was predicted. So in such a way, we are going to find out the different kinds of crop diseases or plant diseases by using CNN algorithm in this project. So next one, accuracy and loss graph. By clicking this button, you can see the graphical representation of loss and accuracy of the CNN algorithm. In the x-axis, you can see the number of iterations, and in the y-axis, you can see the count of the accuracy or loss graph. In the graphical representation, you can see the green line indicates the accuracy, which is increasing when the iterations increases. Then the blue line indicates the loss graph, and this graphical representation decreases when the iterations is increasing. So close this graph and go to the next button, that is exit button. By clicking on this button, you can see the exit of all the code of this program. Now go to the conclusion. So in this project, we have found that CNN algorithm with the recognition of diseases based upon the crops and pest diseases are found with the best accuracy score. By this project, we can recognize different types of diseases and also reduce the economical losses much more.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.